that is missing. Okay, so first, this is about first degree Taylor polynomial because we will use this for our second degree Taylor polynomial. Okay. Um, so the Taylor polynomial approximation to functions of one variable, we discussed that already in calculus 1 or in your calculus 1. Yeah, it was discussed already. So we have here linearization of function f of two variables at point A, B, and we have this formula. So their L of xy is equal to f of AB plus fxab. Again, your fx here is the partial derivative of f with respect to x. And since that's too long, I will just read it like fx. Okay, so fx at point AB times x minus a, and then fy at point AB times y minus b. So what are you going to do here first to get this? You have to get the partial derivative of f with respect to x first, so fy and then fx and fy. Then after that, you substitute the point a, b there, and this one becomes a number. This one is a number also, and then this one is also a number. Then you multiply that with the fx, you multiply that one with x minus a, and then this one you multiply it with y minus b, and you will form a polynomial. Okay. So next, again, this is the linearization L here is also called the first degree Taylor polynomial of f at AB. Okay, next, for the second degree, if f has continuous second order partial derivatives at AB, then the second degree polynomial, the second degree Taylor polynomial of f at AB is this formula. So actually, the first three terms here are from the first degree. They're just the same, but with an additional here, plus 1/2, then multiply the fxx of AB here with x minus a squared. Then the fxy of AB, you multiply it with x minus a times y minus b. And then the last term is 1/2 fyy of AB times y minus b squared. So the approximation f of xy class is approximately equal now to your q of xy. This is called a quadratic approximation to f at AB. So verify that q has the same first and second order partial derivatives as f at AB. So we will now have an example how to solve that. So here we have find the first and second degree Taylor polynomials L and Q of f of xy, which is equal to e to the power of negative x squared minus y squared at 0, 0. So the first degree Taylor polynomial Lxy includes only linear terms. So it will be here f of 0, 0, fx 0, 0 times x minus a. Your a there is 0 because this is 0, 0. So you cannot see a minus here. Then next we have fy 0, 0 times your y minus b, and your b is 0. And now, if you substitute, solve now your f of 0, 0. So f of 0, 0, substitute it here in your f. So this one becomes e to the 0, which is here. E to the 0 is equal to 1. Now we solve the first order partials. Okay, fx first. This one with respect to x. So just copy this one and then multiply the derivative of the exponent with respect to x. The derivative here is negative 2x. That is why there's a negative 2x here. Now you substitute the 0, 0 here because we're going to solve the fx 0, 0. So there's a 0 here in the x. So 0 times negative 2 times the whole thing here, it becomes 0. And then for your fy, this is now your fy, e to the negative x squared minus y squared times negative 2y. Now you substitute there 0, 0, then the whole thing here becomes 0 also. So this one, substitute now the results. Your f 0, 0 is 1 plus this 1 is 0 times x, it's 0. Then fy, which is 0 times your y here, it's 0. So 1 plus 0 is equal to 1. So your first degree Taylor polynomial is just equal to 1. Now the second degree. For the second degree, you are going to solve the fxx, fyy, and fxy because we will use that in our formula. This is our formula, right? Okay. So we solve the three values. fxx first. So since this is your fx, correct? Can you imagine it? It's from here. It's negative 2x times this one, e to the power of a negative e to the power of negative x squared minus y squared. Now, there's an x here and there's an x here also. So we apply product rule here. So first, derivative of negative 2x, it's negative 2. Then copy e to the power of negative x squared minus y squared plus negative 2x should be there. And then e to the power of negative x squared minus y squared. Multiply the derivative of the exponent. Now it's negative 2x, so that is why negative 2x times negative 2x, it becomes plus 4x squared here. This is why this is the number. Now next, substitute now the 0, 0 again. So here there's an x here, multiply the whole thing, it becomes 0. And then here, your x and y are in the exponents, so this becomes 0. So negative 2 times e to the 0. E to the 0 is 1, so multiply with negative 2, the answer is negative 2. That is why the answer here is negative 2. Next, fyy. This is your fy. There's a y here, negative 2y times there's a y here also at your e to the power of there's negative x squared minus y squared here. So what we're going to do, you apply product rule again. So derivative of negative 2y, it's negative 2 times e, and then plus negative 2y copy, then e to the power of negative x squared minus y squared, then multiply the derivative of the exponent. The exponent here, derivative with respect to y, it's negative 2y. So times another negative 2y here, it becomes positive 4y squared. Now we substitute 0, 0 here in your x and y. So this term becomes 0 because there's a y squared here. And then this one on all the exponent here, this becomes 0. So that's negative 2 times e to the 0. It's equal to a negative 2. Now your fxy. You have your fx. This is your fx. Now we take the derivative with respect to y. So since we're going to take the derivative with respect to y, negative 2x there is considered constant. So just put it there. And then what's the derivative of e to the power of negative x squared minus y squared? It's a negative 2y, correct? E to the power of this times negative 2y. Multiply that with the negative 2x. It becomes positive 4xy. And then substituting 0 is your x and then 0 in your y here. The whole thing becomes 0. So your second degree Taylor polynomial is now this one. Copy the result of your first and then plus 1 half times your fxx, right? Negative 2 here. And then we have there x minus a, then squared it. Since your a is 0, so this becomes x squared. Now next, this is 0. The 1, 2, 3, 4, 5. The fifth term is 0 because your fxy is 0. We will use f of xy here, right? So this is 0. Plus 1 half. Then your fyy, which is negative 2 again. And then times y minus b squared. Now since your b is 0, so it becomes y squared. Now solving this is 1. When you multiply 1 half at negative 2, that is negative 1, so negative x squared. And then this one is negative y squared. And we have our second degree Taylor polynomial equal to 1 minus x squared minus y squared. Okay, next. This one, the del F is equal to lambda del G. Okay, this is your Lagrange multiplier, the lambda there. So the procedure based on equation one as is as follows. So method of Lagrange multipliers so to find the maximum and minimum values of f of xyz xyz is equal to k. Assuming that these extreme values exist, then the del g is not equal to 0 and the surface g of xyz is equal to k. So find all values of xyz and lambda such that the del f is equal to this one and then g of xyz is equal to k. Okay, next. Here for your del f, uh, as you know that the del f here is your fx. If this is your fx, here is also gx here. If this is gy here, the other side here must be g. If this is fy here, this is gy here in the other side. If this is fz, this is g of z here, gz. Okay, I am referring to the partial derivatives with respect to x and y, z there. Okay, next, and we have this constraints. Your g of x, y, z is equal to k. Okay, now next, letter B. Evaluate f at all points x, y, z, and that results from step A. Then the largest of these values is the maximum value of f, and the smallest is the minimum value of f. So if we are going to solve the values here of our x, y, z here, so maybe we can get two values for x, two values for y, and then two values for z, for example, and then just substitute that in your f, in your function f. So the highest value there is the maximum, then the smallest is the minimum. Okay, so let's have this as an example. A rectangular box without a lid is to be made from 12 meters squared of cardboard. Find the maximum volume of such a box. Okay, so you have a cardboard, and then we are going to form a rectangular box using it. And now the question is find the maximum volume of such box. Okay, now for the volume of a rectangular box or rectangular prism, it's equal to the length times width times height. So if we let their x, y, and z be the length and the width and height respectively, yeah, their v is equal to x, y, z, subject to the constraint. Um, this is now your constraint. Why is this the constraint? Okay. Class, can you imagine a box without lid? So without cover. Okay, that is what it means without cover. Okay. Um, the rectangle, the rectangles there at the side of the box. Okay, the rectangle there at the side of the box. We have there. Um, if your if your rectangle at the bottom of the box is the length times width, so that is x times y. And since there is no cover, so only xy is here. Okay, so this one is at the base of your rectangular box. Okay, the lower base of the box. Now, okay, I have a box here. You just imagine it. For example, this one, and then there is no cover. There's no cover here. So your xy is here. This is your rectangle xy. Now, since the height there is z, so this one, the height of the box here is z. This length here is z. So if this is equal to x, okay, if this is your length x, and then this is your z, so we have this rectangle here, and we have this rectangle here. So you have there two of your xz. So it's here, 2xz. And then if this is now your xz, right? And then this is your xz. This part here, this rectangle is your yz because this is now length y, and this is the height here is z. So the area here is the width times the height. So that's y times z. And another here, the other side, it's also y and z, right? Y times z. So we have there five squares in your box again because there is no cover on top. Okay, that's it. We have there 2xz plus 2yz plus xy is equal to, since your cardboard is 12 meters squared, so it should be equal to 12. So using the method of Lagrange multipliers, we look for values of x, y, z, and lambda such that delta of v is equal to lambda delta g and then del g, and then g of xyz is equal to 12. This gives the equations. Okay, this one, as I told you, if this is vx, the others, your g here must be with respect to x also, so lambda gx. Vy here times lambda gy, and then vz times lambda g of z, and then your constraints, which is this one. Okay, now we solve. What is the derivative of your v with respect to x? So it's just their yz. So yz is considered constant. So that is your derivative, right, with respect to your x. Now, what's your derivative with respect to gx? Look at your g class. This is your g. What's the derivative here with respect to x? This one, the derivative of this is 2z, and this one has no x, derivative this is 0, and derivative of xy is y, so we have a 2z plus y. Okay, continue. So it's there, 2z plus y, and then your vx is yz. So this is your vy, this is your gy, this is your vz, and this is your 2x plus 2y is your gz, correct? As you can see here, we go back, your GZ, Z are here. So derivative of y is 0. So now with respect to Z, we have there 2x plus 2y is the derivative, correct? And that is why this is your last result here. 2x plus 2y, and then xy is your derivative with respect to Z here in your V. That is your VZ. VZ is equal to xy, correct? And that's it. Now, um, this is your constraints. Now, class, what are we going to do is, it says here, in the present example, you might notice that if we multiply 2 by x, so here, class, we multiply the second equation by x, 3 by y, we multiply this by y, and then the fourth equation, we multiply all by z, and this will be the result. So as you can see, they are all now xyz, xyz. Okay. Now, since they are all xyz, the whole thing here are all equal with each other. This one is equal to this, and then this one is equal to this. Okay. Now, we observe that your lambda there must not be 0. Why? Because there's a reason here. If this is 0, 0, 0, what will happen there? Okay, look at there at the top. If your lambda is 0, lambda 0, lambda 0, your your yz, xz, and xy are all equal to 0. It's here. Yz, xz, yz is equal to 0. From 2, 3, and 4. It's from here, from 2, 3, 4. Correct? Now, this would contradict number 5. It will contradict the number 5 because if your xz there is 0, so 2 times 0, your yz is 0, then your xy also is 0, so all of them are zeros. It will not be equal to 12. Therefore, your lambda is not 0. So we have to find the value of the lambda. Okay, now next. Since your xyz is equal to xyz here in 7, so we have here 6 and 7. From 6 and 7, these two things are equal. Correct? The 2xz plus xy is equal to 2yz plus xy because it's the same here, xyz and here lambda. Therefore, these two are equal. Correct? And that's it. Now, class, as you can notice here, this is xy and this is xy also. So therefore, the 2xz here in the first term is also equal to the first term here, which is 2yz. Correct? Because they just added 2xy there. So we have there 2xz is equal to 2yz. And after that, divide 2 both sides. So it will give you xz is equal to yz. It's here. Again, that's from the 2 there. With the 2xz is equal to 2yz, then divide 2 both sides. You got this. Now, your z class should not be 0. Correct? Because if your there's a reason here, if your z is 0, your volume becomes 0 because your volume formula is x times y times z. Now, since z is not 0, class, we can divide this by z, right? Divide z both sides because is just a number. You cancel out z there, your x is equal to y. Okay, so from 6 and 7, it says that your x is equal to y. Now, combining the 7 and 8, okay, if you go here, this is your seventh equation, and then your 8. So there's 2yz here plus y plus xy, then 2xz is equal to 2yz. Okay, and are the two, these two will be equal. Now, as you notice here, class, this is 2yz here, and the last here is also 2yz. So what can you say about the 2 here? The 2 should be equal, right? The 2xz is equal to xy. Now, since x is not 0 also, class, because again, the reason, if your x is 0, your v becomes 0. So we can divide this by x, divide this by x. Okay? And after that, we have the 2z is equal to y, or y is equal to 2z. And combining our result in the 6 and 7, we have there x is equal to y, right? So x equals y, combine here. So your y is equal to 2z. Now, you substitute the value of your x and y now in the constraints. Here, number 5. Your x, y, okay? So we substitute it there. X and y is equal to 2z. So substitute there. We have 4z squared. If you substitute that with 2z, here also the second 2yz, your y is 2z, so it becomes 4z squared here also. And then x times y, so your both x and y class is equal to 2z. So 2z times 2z here, it becomes 4z squared. Correct? Now, since all of that are now z, okay, that's the hint, class. You substitute the x and y here in terms of the z so that you can solve the z value. Now, 4 plus 4 plus 4, this is 12. So this is 12z squared. Divide 12 to the other side. So we got z squared is equal to 1, correct? Now, z squared is equal to 1. Transfer the squared to the other side. You have to take the square root both sides. Now, if you take the square root both sides, you have two answers for z, a positive value and a negative z, correct? Z is equal to a positive 1 and z is equal to negative 1. Now, there's a reason here. Since your x, y, and z are all positive, why they're all positive? Because we are referring, class, to the length of the box. There is no negative length. So that is why instead of having positive and negative 1 for z, we can only pick the positive value for z. So z here is 1. Now you substitute it here. Your x equals y equals 2z. So your z is 1. Therefore, 2z is equal to 2 times 1 is equal to 2. Therefore, both x and y are equal to 2. So here, so X equals 2 and Y equals 2. So you have your values now of your Z, X, and Y. They are not zeros. We have here 1, 2, and 2. Okay, we go back. What is the question, class? Find the maximum volume of such a box. Did we answer it? What's the answer? By the way, the book didn't give the answer. What's the answer, class? The maximum volume of the box is? Can I see it there in the chat box? I hope that you are listening. What's your answer? Class, what's the maximum volume of the box? Hello? No one? No one can answer? We solved the values already. The x is 2, your y is 2, your z is 1. What's the formula of the volume again? Correct. Someone asked, is it 4? Yes, it is 4 because your volume is equal to x times y times z. So multiplying 2 times 2 times 1 there is equal to 4. And 4 is the maximum volume. Okay? And that's it. So here in this example, they just give the value of the z there, x and the y, but didn't give actually the answer to the question. Okay, next. Find the extreme values of the function f of xy is equal to x squared plus 2y squared on the circle x squared plus y squared is equal to 1. So we are asked for the extreme values of f subject to the constraint. Your constraint is this, the circle, equation of the circle, right? So using Lagrange multipliers, we solve the following. We solve the equations. Del f is equal to lambda del g. So here, first, we can have this, right? Fx is equal to lambda gx, then fy is equal to lambda gy, and then your g of xy is equal to 1 because it's here in the given. Okay, now, what is your fx? Go here. What's the derivative with respect to x? It's 2x. Also, in your g of gx here, just as your gx, y. So the gx here is also 2x, correct? So that's 2x is equal to 2x lambda times lambda. Next, your fy here is 4y. And then your fy here in the g of xy, your gy here is 2y. So you have there 2y lambda. And then this is you copy the constraints g of xy, which is this. X squared plus y squared is equal to 1. Now we solve the value of the lambda. Okay, from 9, here, equation 9. Um, Either x here is 0 or lambda is 1. Correct? We have there x is 0 or lambda is 1. Why? If your x class here is 0, what's the value of your y? If x is 0, then 11 gives you what? So if your x is 0 here in equation 9, this will be true, right? This is 0 is equal to 0. Now you substitute that in your 11. If your x is 0, so that is 0 squared or 0 equals y squared is equal to 1. We have there y squared is equal to 1. So what to do? Take the square root both sides. So your y has two answers, positive and negative 1. So we have here gives y is equal to positive and negative 1. Now if lambda is 1 class, if lambda is equal to 1, then y is equal to 0, correct? Look at here. If your lambda is 1, you have there 4y is equal to 2y. After that, transfer 2y to the right. the other side, it becomes 4y minus 2y is equal to 0. 4y minus 2y is equal to 2y. So 2y is equal to 0. Divide to both sides your y. We have your y is equal to 0 from your 10. Now substitute the y is equal to 0 here in your 11. Okay, so first here the value of the x, we got 0, so that is why we substitute it here. For number 10, we also get a value of 0 of your y there, and then we substitute it here. Now your x, you can take the square root of both sides, so your x is also positive and negative 1. Therefore, f has possible extreme values at the points. Okay, you have to compare them. First, 0, partner it with positive 1, so it's here. 0 of your x, and then a negative 1 in your y. Next, here in the second case, your y here is 0, then your x here is positive 1, you have there 1, 0, and another y is equal to 0. Then, since you have two values of x here, we have also negative 1, 0. So we can form 4 points from the results. And I'll substitute that in your f, in your function f there at these 4 points. So let's try um, 0 0 1. Your y is 1, and then your x there is 0. So here, your x is 0, this is 0. Now when your y is 1, so 1 squared is 1 times 2. So your f of 1 0 is, if your f of your 0 1 is 2. The f of 0 negative 1 also is 2. The f10 is 1. The f of negative 1 0 is equal to 1. Okay, next. Okay. So we get the following values. For the maximum there, as you can see, it's the 2. 2, right? Because here the answers here are all 1. So the maximum value f is f of 0, 1 and f of 0, negative 1. So you have your f of 0, positive, negative 1. The answer is 2. Again, class, the maximum value is 2 at the 2 points. The 2 points there is 0, negative 1, and 0, 1. Okay? If you will be asking, like, what's the maximum value, the answer is only 2. Okay? But you have there 2 points in your values for your xy. Now, and the minimum value is 1, which is here f of positive, negative 1, 0. And at this point, the answer of your f is 1. So checking with figure 2, we see that these values look reasonable. Okay, you can see it here in the graph. If your f is, as you can see here, um, negative 1, 0, your x is negative 1, and 1, 0, it's only 1. Here, this is your positive 1 here in this is your graph, and this is the circle here. So we only consider the points on the circle, and then get the reflection here in the graph. Okay, so if this is 1, 0, the value of the z is here. This is your f of xy. Okay, and this point here is located in the lower part. So this is the minimum. Now here, this point, okay, we go back. It's f of 0, 1. Yes, this is your f of 0, 1 here. Now, if you go straight that one to the top, it's right here. And it's also 1. obviously the highest point here. That is why it is the maximum. Okay? And that's it. There also the previous side of the x, it's lower. And then here it's the highest here also, the other side, this point here. And that's it. Next, find the extreme values of x, f of x, y, z equals x squared plus 2y squared on the disk. X squared plus y squared is less than or equal to 1. Plus the difference of this from the previous example is that we only have the circle. Look at here. The function are the same, but here is only the points on the circle. X squared plus y squared is equal to 1. Parts of the circle, right? Only the points on the circle. Now, since the second example that we have here is a disk. What does it mean by the disk here? This is x squared plus y squared less than or equal to 1. If you graph this, the points inside the circle will satisfy also. So we will consider all the points there on the circle and inside the circle. Now the same, we have there the same process that we're going to solve. Now, if you get the fx and you get the fy, we take first the critical point. So here, equate this to 0. 2x is equal to 0, so your x is 0. Your fy is equal to 4y. Now equate that to 0, so 4y is equal to 0. Your y is also 0. And we have the critical point f at 0, 0 point. Now, we substitute that additionally here in your f of 0, 0, here in your f of xy. And this is 0 squared plus 2 times 0 squared. The answer is 0. Now, what will happen is the results are still the same for your f1 and f of negative 1, 0, which is 1 here. Your f of 0, positive negative 1 is always 2 because it's from the previous result that we had. Now look at the maximum value is still 2. Still, it's always equal to 2 because this is the higher here, the highest among the numbers. Now the minimum value changes. It's not the 1 anymore. The f of 0, 0 is 0, so this is now the minimum value. Okay? Now if you see the graph there, yeah, the point here in the 0, 0 is you will get the smallest of the z there, which is true because this is the graph, right, of your z. Look at here. The point 0, 0 is here in your x and y, and the point in the z there is the minimum, the lowest point, which is your z there is 0. Okay? So it is not this point anymore because here the z here is 1. Okay? And that's it. We only change the value of the minimum there, which is the f of 0, 0. And then when you ask me like, oh, why the point there now is considered as a point, uh, again, class, that is a critical value. And then our, what do you call this? Our constraint there now is a disk. So if that's a disk, all the points here inside the circle are considered parts of the points. So here, the points here are all parts, and then the lowest is should be there, the 0, 0, and then your f of xy there is also 0. Okay, and that's it. That's the lowest of them all. Now next we have, this is the graph there. Um, this blue one is the circle x squared plus y squared is equal to 1. Okay. And now this pink circle here, this is the x squared plus 2y squared is equal to 1. And then the pink one here, the last pink circle is x squared plus 2y squared is equal to 2. Okay? And that's it. Next, Mm. So as you can see, class, you can see it here actually. This is the point. What is this point again? This point here is the 0 is your x. Here is the 1. So this is 0, 1 point. It intersect your uh, the graph here. X squared plus y squared is equal to 1, the blue one. Okay? This point is the negative 1, 1, a negative 1, 0. This point here is the 1, 0. And then this point here is the 0, negative 1. Okay? And they intersect the circle. And the 0, 0 point is here inside. And that's it, if you can imagine it. And this is the minimum if we consider all the points here inside the circle, the blue circle. Next, what if we have another function there? So del f x y z f x sub o z y sub o z sub o, then lambda times the del g plus. So since this is for lambda for the g, and we have to put another variable here, mu for your del h. So this symbol here is represented by a constant. So this one must be a number. We have to solve it. Okay. Now, um, in Lagrange's method to look for extreme values by solving five equations in five unknowns, we have there x, y, z. There are unknowns. Lambda is unknown also, and mu is unknown. Unknown. Okay, here fx, we have the lambda gx plus mu times hx. Okay, this is for the y, this is for the z, and you have their g of xyz is equal to k, and another constraint, we have h of xyz is equal to c. Okay, next. So we have this example, maximum value of this function on the curve of the intersection of this plane and this cylinder. So this one, class, now is your g of xyz, and then the cylinder is your h of xyz. Now we solve the Lagrange condition. This one, del f is equal to lambda del g plus mu del h. So first, with respect to x, now derivative of the x here is only 1 plus lambda. Derivative of the x here in your g is 1 only, so that's times 1 there, plus. Now derivative of your x here in the h is 2x, so 2x times mu. Next, 18 with respect not to y. F with respect to y, we have 2. And then equals here. G is negative 1 multiplied with lambda, so negative lambda. Plus mu. Derivative now of x squared plus y squared with respect to y. We have there y squared, so make it 2y there. Okay? Now the last is the z. For the z, derivative here is 3 is equal to the z here is 1. So 1 times lambda, and then plus. Oh, there is no z here in the h. So its derivative, all of this, x squared and y squared are all 0 times the mu. So you cannot see it here. Now, as you can see, we have a lambda already. Your lambda is equal to 3. And next we have again 20. Copy your g, which is this one, and then copy your h. Your h is this equation, x squared plus y squared is equal to 1. Now, class, since your lambda is 3, what will happen here? 17. If this is 3 here, transfer 3 to the other side, it becomes negative 2. Correct? Because you minus the 3 here. 1 minus 3, it's negative 2. So 2x mu is equal to negative 2. And it's here. 2x mu is equal to negative 2. Solve now the x. So divide 2 mu, divide 2 mu, and your x is negative 1 over mu. Similarly, in your 18, 18. Go back to 18. This one, if your lambda is positive 3, which is here, so transfer it here to the other side, so it becomes 5 there, right? 2 plus 3 is 5. Now divide 2 mu, so it becomes 5 over 2 mu. That's your value of your y, which is correct. It's here. 5 over 2 mu. Now you substitute x class and y in the 21 equation. This one. Substitute it here and you get this. Negative 1 mu, you square it, it's 1 over mu squared. And then 5 over 2 mu, you square it, it's 25 over 4 mu squared is equal to 1. Now we solve the value of the mu there. Solving the value of the mu class, you can get mu squared is equal to 29 over 4. Now take the square root both sides. You have two answers. Your mu is equivalent to positive and negative square root of 9 over 2. Now, if this is your mu, you substitute it here in your x, and you will get two values of your x. You have there a negative because you substitute the positive first in your mu. So negative divide positive, it's negative. That's why the first answer is negative. The second will be positive. So minus plus 2 square root of 29. This is now your x. Now for your y, you substitute there the positive square root of 29 over 2, and you will get 5, positive 5 over square root of 29. So it's here. Positive is written on top, so that's plus there. Now if you substitute the second one, which is the negative square root of 9 over 2 here in your y, cancel the 2 there, it becomes a negative 5 over square root of 29, which is this. So you have the x, you have a y value. Now from 20, you go back to 20 because you have additional formula here, 20, right? Now you substitute the value of your x and y here so that you can get the value of our z. Now, this is your z now is equal to 1 minus x plus y, correct? Because you will transfer the x there to the other side, it becomes minus x. Then transfer y to the other side, it becomes plus y. So it's here 1 minus x plus y equals, this is the value first when you substitute the value of your first x. Your first x here, class, is the negative 2. Negative 2 square root of 9, you substitute it here. There's a minus here, so minus negative, it becomes plus. So positive 2 square root of 29 plus y. Your first y here is the positive, so plus 5 square root of 29, and that is now 7. So it's here, 1 plus 7 square root of 29. That's the first value. Now, second value, if your x is positive 2 square root of 29, you substitute it here. Since there is minus here, it becomes negative. And now the second value of your y is also negative, so negative 5 over square root of 29. So the other z result now is this one, the negative 7 over square root of 29. So that's 1 minus that value. Now you have now your z value, your x and y. So you substitute it here in your f of x, y, z. Okay, this is x plus 2y plus 3z. So it's here x plus 2 times y plus 3z. So your first x here is negative. So it's here negative will be typed in your calculator, and then 2 plus for your y. And then for your z is the plus also. So 1 plus 7 over square root of 29. And when you solve them, it's positive. So we have 3 plus square root of 29. Now next, the positive of the x, you will substitute the negative of the y, and then the negative of your z here. And you will get the 3 minus square root of 29 also. So we have the two values, 3 plus and 3 minus square root of 29. So which do you think of the values is the maximum? So it's very clear that the maximum is the plus, right? We have there 3 plus square root of 29. And that is the answer. Okay? Next. So thank you for listening. That is actually the end of your chapter 1. So I will now give you your 10-minute break. Then we will continue with the chapter 2.
Teacher, will you upload the slide onto BKL because for us to recheck it again?
Oh, it's not there?
No, no, it's not there yet.
Okay, wait. I will upload it. It's not there. Okay. Copy. It's calculus 2. TT. Okay, it's there already. Okay, hello. Can you hear me? Okay. So I will now share again the screen. So let's continue with the chapter 2, part 1, right? We stop at gradient vector. We're done. I no, no, wait. We stop at TTO1, um, slide number 37. Okay, so before we proceed with 37, I will just show you something. I guess I forgot about this. Um, we have this example, and we solved the double integral of this from 0 to 02 here, and the value that we get is 48. But class, as you remember, we solved this already using our Riemann sum. So for the Riemann sum, expected that it should be lower than 48, and because that is just only approximation, and you can see it here. Oh wait, the Riemann sum that we have is this one. As you can see, the same z equation, and your r is also the same from 0 to 02. And we have the first approximation is equal to 34. And then when we have 2 many squares there, so that's for the 34. Now, if you have too many boxes there, okay, your V here is 41, here 44, then the last V here is 46.46. So this is the approximation. And the real exact value there must be 48, right? Yeah, if you solve it using the double integral, which is this one. Hmm. And as you can see that, yeah, the Z is here, they're just the same, and this is your R there. 48, and as you can see also in the figure, this is this almost the same with that figure. Okay? They're just the same graph. Okay, now we stop at 37, which is this one. So double integrals over general regions. So what if your region now is not a rectangle anymore? So what if it's look like this, D here, this one, the surface D here now, or the region D. So what are we going to do, class, is we are going to form a rectangle there such that the new region is inside it. Okay. Now, your f of xy, this is the domain, the set of the domains are here in this region, bounded in this region. And then now, your capital F of xy is equal to your f of xy. If xy is in D, it should be is in D. Now, your capital F of xy class is equal to 0 if it is not in D. So it is in the R here in the blue part. Your f there, your f of xy is equal to 0. So that is why, class, these two functions are just equal with each other. Okay? Because it's equal to this one, the small f, if it's in D. But if the points are outside, it's 0. So when you take the double integral of that, they're just equal. So it's here. Now, the double integral of the small f of xy under the region D here over the D is equal to the double integral of your capital F of xy dA over region R. Okay, so it's here. Actually, this is your graph of f, the blue one here. Then this is the surface D here. So in your f, the graph is also this one. So the same graph. Why? Because it will only reflect the graph here in the D part. Because in outside the D there, the value is zero, so there is no parts here that will be added. So they're just the same. Okay? So the double integral of these two functions are now equal. Next, um, you have there if f is continuous in a type 1 region such that we have here d is bounded from a to b, and then your y is bounded by two functions g1 of x and then g2 of x here. So now one of your variable now is bounded by two functions. Okay, so if it's bounded by two functions class, so if you can imagine it, it looks like there's a function here and then there's a function here on top, and then just get the volume. Okay, so um this one is for the type 1 if your y is bounded by two functions. Number 4, this one is a type 2 if your x now is bounded by two functions. Your y is just bounded by an interval from C to D. Here, your x is bounded from an interval A to B. Okay, now, if you're going to solve this, the number which is bounded by the interval will be the last integral that you're going to solve. Okay, so since x is here, dx is the last here. And then it should be bounded by interval from A to B, evaluated from A to B. You know why? Because your y here is bounded by a function of x. So what will happen is, in your f of xy, you solve the integral. Then after that, you substitute the x's there, the functions with x. And then what will happen is, all the results here inside becomes a function with all x there in the variable. And then now, since the variable is all x, now you can integrate that and then substitute the value of x here by first b, right? You substitute the b there first, then minus, you substitute all the x there by a, and then you can solve now the double integral, and that is now a number. Okay, now, what if you interchange this? You have there the integral of AB first, then G1, G2 is here, then you interchange also dy and dx there. Class, if you interchange that integral integrals, what will happen there is, in your final answer, it is not a number. Okay? In your final answer, the result is not a number anymore, which is contradicting to our volume because the volume must be a number. Okay? It is not a number anymore because you're going to substitute the last there as a function that's function of x. So what will happen is your answers are all containing x. Okay, are terms with an x there. So here is your type 2. Okay, and then I will show you an example. So we have this one. uh, Evaluate the integral x plus 2y is equal dA, where d is the region bounded by the parabolas y is equal to 2x squared and y is equal to 1 plus x squared. So what are you going to do now, class? Your y is bounded by two functions here. Your y is bounded by two functions. So all you have to do is um, to solve the values there. Which one of them is the higher function? Okay, as you can see here, 2x squared is here, less than or equal to y, less than or equal to 1 plus x squared. Okay, so what happened now? This one is higher, this one is larger. 1 plus x squared is larger than the 2x squared. Is this true? So not all. Okay. Um, First, we solve the x there, the interval of our x, because it's not given. Okay? Since it is not given, 2x squared is equal to y, and then 1 plus x squared is also equal to y. Therefore, the 2x squared is also equal to this 1 plus x squared. Correct? Because both of them are equal to y. After that class, transfer the x squared here to the other side. It becomes minus x squared. So 2x minus x squared is x squared. So x squared is equal to 1. That would be the result. Take the square root both sides and you have two answers for your x. Your x is equal to negative 1 and 1. And that is now your values for your x. That is now the interval. So your x is from negative 1 to 1. Now, why is it that when you have there an x squared, multiply it with 2, why is this lesser than your 1 plus x squared? So as you can see, they are the same x squared, the other one plus 1 only, then the other one times 2. Why is this now lesser than this? What do you think is the reason? Hello? What do you think is the reason why 2x squared is less than the 1 plus x squared? Again, you have to determine which of the two function is higher in the graph. What's your answer? Why? What's the reason there? Why your 2x squared is less than the 1 plus x squared? The other one, it multiplies 2 there. While the other one only plus 1, x squared plus 1. Why is that higher than the 2x squared? Hello? What's the reason here, class? Why this one is larger than 1 plus x squared? What's the reason here? Let x equals 0. Other? Other reason? No one? The other class answered it? How about your class? Hello? What's the reason behind there? Why is it that 2x squared, 1 plus x squared will always be positive? The 2x squared is also positive. As you can see here, I multiply the x squared with 2, and then this one is only plus 1. Why is this higher? X squared larger? They're both x squared. Both of them contains x squared. Again, the smaller number is the 2x squared, and then the larger one is the 1 plus x squared. Why is that so? Hmm. Someone has an explanation here. If he let the x there be 0, the 2x squared is 0, while the x squared plus 1 is 1. Hmm. You have an idea there. Huh? Yeah, your idea is there already. If you have the 2x squared, you substitute x is 0, it's 0. While the x squared plus 1, the answer there is 1. So the x squared plus 1 now is larger. What do you think is the reason? You cannot only give me a value of x which is only 1. Okay, class. By the way, the answer is since your x value is from negative 1 to 1. And then the values there, if you substitute in that 2, the x squared plus 1 is always larger than the 2x squared. And you can see it here in the graph. Um, we will graph it using Desmos graphing calculator so that you can clearly see it. Y is equal to 2x squared. And then here we have y is equal to x squared plus 1. Hmm, it's here, class. Look at the graph here. The blue one is the x squared plus 1. This is the blue one. So from negative 1, the value here in this point is negative 1. And this one is 1. So from negative 1 to 1, so as you can see, the blue graph, which is x squared plus 1, is at the top of the 2x squared. The 2x squared is here, the red one. So this one has a smaller number here compared to your x squared plus 1. Okay? So actually, it has a graph there also. Okay, so that is why 2x squared is here, then your 1 plus x squared must be here. It is higher than that. So since the lower boundary is y, this is your lower boundary, and then this one will be the upper boundary because, again, if you graph it, it's there in the upper location, right? In that interval from negative 1 to 1 in your x. Okay. Now what are you going to do now? You substitute now the values, double integral. So your x is from negative 1 to 1. Then your y is 2x squared to 1 plus x squared there. And then your function is 2 x plus 2y. So since this one is the interval for your y, so you have to write dy first, and then last is the dx. Now solving this, the integral of x with respect to y, because this is dy, so your x there is considered constant, so just multiply it with y, so that becomes xy, plus the integral of your 2y, it becomes 2y squared over 2. So just cancel the 2, it becomes y squared. Now evaluate that from 1 plus x squared first, you substitute in your y there. This would be the result. X times this is your y, plus your y squared. This is your y squared. Now substitute the 2x squared down. This becomes minus. So minus x, substitute here in your y. So x times 2x squared. And then minus also, again, you substitute the 2x squared squared, and you have there now dx. Now your calculator can automatically solve this even if you will not simplify it. So if you do not have enough time, you can just type this one rather than simplifying it and get the integral again. Okay. Again, your calculators can solve until there, until here. It's not a single integral, so it can be calculated with your calculator. So if you can solve this one, multiplying the terms and then add the common terms there, and it becomes negative 3 to the fourth minus x cubed plus 2x squared plus x plus 1 dx. Again, for this one class, you will use this in your project because I want that your project has a detailed solution, not too many shortcuts. Okay, so after this one, you have there a log power rule. This is x to the fourth, so it becomes x to the fifth over 5, correct? This is x cubed, it becomes x to the fourth over 4. The 2x squared becomes x cubed over 3. The x becomes x squared over 2. Then the constant 1, we'll just multiply that with x. And then evaluate it from negative 1 to 1. So first substitute 1 first, then minus you substitute the negative 1. And your result there becomes 32 over 15. Okay? But this one, if you solve this using your calculator, it will give you automatically 32 over 15. Okay, next. Oh, the graph is here actually. Your y is equal to 1 plus 1 plus x squared is here. It's higher than your y here. Your y is equal to negative 2x squared. And this is the arrow. It's going there. So that is why this is type 1. Correct? If it will go up. So if going to the side class, that's type 2. Okay, you will I will give you another example later for the type 2. Here, This is type 1 again because so now it's the volume of the solid. This is paraboloid, and then this is your bounded by the line y is equal to 2x, and the parabola y is equal to x squared. Now to solve the value of the x there, which is 0 and 2, so what to do, equate this. They're both equal to y, so your x squared is equal to 2x, correct? X squared is equal to 2x. Transfer 2x to the other side. It becomes x squared minus 2x is equal to 0. Now factor out x. You have there x times x minus 2 is equal to 0. So solve the x's there. X is equal to 0. And then x minus 2 is equal to 0. And that means that your x must be equal to 2. So you have the two values of x, the 0 and the 2. And it's here, 0 and then 2 here. Now for your y, again, you have to consider only the values from 0 to 2. So class, if you are confused which of them is higher, you substitute maybe the value inside it. So it's 0 to 2, you substitute there 1. You try. So here, this is 2x and this is x squared. So when you substitute 1 here in the x squared, it becomes 1. Now if you substitute 1 here in your 2x, 2 times 1, it's 2. So therefore 2x is higher. Now, if you will graph this, the y is equal to 2x is there on top, then your y is equal to x squared. I guess the graph is here in the next slide, and it's here. This is your graph y is equal to 2x. It's a line, so it's there. It's located in the upper part, and your y is equal to x squared is here in the lower part. So this one is the lower boundary now. Okay, x squared is here, and then 2x is larger in your interval from 0 to 2. But if you will go up, class, since this is squared, this is larger than the top part, right? If you analyze it, it's there. As you can see, this graph now, look at it. If it will go up, it's now higher than your x minus 2x. Because here you only multiply it with 2 in your x, and here you square the value. So this one must be, it's too big, or it's a bigger number if you exceed here from 2 to infinity, correct? It will become a very big number there than your 2x now. Okay, now we solve this now. Again, the same, 0, 2 here, and then x squared here, then 2x on top, then copy the x squared plus y squared here. So since this one is bounded by your y, so dy is first, then dx is the last one. Then take the integral of this x squared. There is no y here. We are going to solve the integral with respect to y first because dy is here. So since that is considered constant, just write y beside it and then plus your y squared becomes y cubed over 3. Now evaluate that from 2x from x squared to 2x. Now substitute 2x first, then minus you substitute the x squared, and this is the result. And in combined like terms, you have this one. Now take the integral again. You have there x to the 7 over 7, then times 3 here, it's now 21. Here your x to the 4th becomes x to the 5th over 5. And here your this is x cubed. So plus 1 it's x to the 4th. So it becomes x to the 4th over 4 here. Then 3 times 4 is 12 now. So you have that 14 over 12, and that is reduced to 7 over 6. So we have there 7 over 6, x to the 4th. Evaluate this to 0 to 2, and the answer is 216 over 35. No need to substitute the 0 there, class, because all of the three terms become 0. So just substitute the 2 there and then calculate it. Okay? Now, um, during your test, again, if you are in a hurry, you can stop here in this part. Do not take the integral anymore. Just solve this integral in your calculator, and your calculator can solve this. The answer is 216 over 35. Okay, next. Wait. Again, this is for the type 1 region. Okay, your D is type 1 region because your Y, your X there element in the interval, and then your y there is between the two functions. Next. Okay. Now, if you wanted to solve it type 2, it's okay. Look at here, class. The type 2 is going to the right. So if it's going to the right, class, you have to solve the x's here. Here you solve the y. Now you solve the x. Here, if you solve the x here, divide 2, both sides divide 2. So you have there x is equal to 1/2 y. It's the same with y is equal to 2x. Now your y is equal to x squared is here. Take the square root both sides. It's the same with x is equal to the square root of y because it is here in the positive part. The graph here in the left side, class, is equal to x is equal to the negative square root of y. But we are not using it here, the negative, right? This one. The x is equal to the negative square root of y, which is the other side here. So we have here x is equal to square root of y. We have this one. Okay. Now you have there your x. Now what is your y? Your y there must be number. Okay, so as you can see the graph, your y here is straight with 0, and you end it here. It's straight with 4. Okay, so what are you going to do there? You integrate it from 0 to 4. And then next we have the lower here is still here. No, left. You start from the left plus going to the right. So the left is here. So 1/2 y must be in the lower, and then square root of y must be on top. I guess so. And it's not here. Okay. Again, class, that's from left to right. Okay, we go back here. Your 1/2 y, class, is in the lower integral, and then the square root of y is there on top. If you're going to solve that one, class, the answer is still the same. We go back here. The answer that you can get is still this one, 216 over 35. Okay. Again, that's from 0 to 4 there. Then change the x here. It's 1/2 y, and then square root of y there on top. Copy x squared plus y squared. And this is not the y dx anymore. It should be there dx dy. It's not dy dx. Okay? Because we changed the values, right? It's here now. Okay, next. Okay, look at here. The y here is equal to x minus 1, and we have a y squared is equal to 2x plus 6. This is double integral of your xy dA, where d is the region. This is now your region D. Okay, bounded by the two equations. Now, if you graph this, um, y squared is equal to 2x plus 6 is this graph. Okay, this is the graph. Now, y is equal to x minus 1 is this graph here. Now, that is y squared, class. So you solve the y here. So take the square root both sides. This graph here, the upper graph, is the square root of 2x plus 6. The lower graph here is the negative square root of 2 pi over 6. This one now is, if you're going to solve it in the type 1 region, this is very complicated because as you can see, it's from the lower going up, right? So there's a part here. As you can see, class, the lower of the graph here is the square root, is the negative square root of 2x plus 6, and the higher is this. And this one in this part here, in this area, we have this is the lower, y is equal to x minus 1, and the higher is this, the y is equal to square root of 2x plus 6. So you have the different lower, right, and the same higher value. Okay, so you cannot use this. Now if we are going to solve it from left to right, it's only one, right? As you can see, all the points here going to the right. So only one line, right? Mm. And um, and that's it. This is the left and this is the right part. So there is no, there's only one unique equation from the left going to the right. So we are going to use this, the type 2, not the type 1. Okay? So for your type 2 class, you get the integral there, the interval of your y there. So as you can see in the graph, this is the intersection and this is the intersection. If you will graph the two, okay? So here, your y value starts here, negative 2. Going here on top, it's stop with the 4. Here, it's straight with the 4. So your y is from negative 2 to 4. And your x is between this one, y squared over 2 minus 3 here, and y plus 1. So how to solve the x's class? Just solve the x here. You have there y is equal to x minus 1. Transfer the 1 to the other side. It's x is equal to y plus 1. Now here also we have here a y squared is equal to 2x plus 6. Transfer the 6 first. You have there y squared minus 6. Then divide 2. You have there y squared over 2 minus 3, which is this one. Correct? Y squared over 2 minus 3. And this is now, you can write it like this. 1 half y squared minus 3 less than or equal to your x less than or equal to this. X is equal to y plus 1. Okay? Because your x there is between the two graphs there. And now we will use this one to solve it. We make now our double integral. So it's there from negative 2 to 4. This is 1 half y squared minus 3 to y plus 1 half. Again, it's just xy there in the given. Here, xy dA. Then replace dA now by, since this one is boundary of your x, we have the dx first. And then this one is boundary for your y. Your y belongs to this interval from negative 2 to 4. So you have to write their dy in the last part. Now solving this one, the integral of this with respect to x first because this is dx. So you have the x squared over 2. Just copy the y there because y is considered constant. Now substitute the y plus 1 there. So we write the y outside. Then we substitute the squared there. And we also write the 1 half outside, which is here. This is over 2, right? 1 half is now here. So substitute here in your x, we have there y plus 1 squared minus, we substitute the lower part here, so that's 1 half y squared minus 3, then squared. Now solve the squared here, then solve the squared here, then multiply them with y. Then after that, arranging them, and you will get this. You have there negative y to the fifth over 4 plus 4y cubed plus 2y squared minus 8y dy. Now, class, if you are in a hurry, you can solve this directly. The second line there, your calculator can solve this directly without simplifying it to this one. Then after that, again, your calculator can solve the second line already and it will give you 36. Can you try it there? Next. If we continue the solving part, we have this one and then take the integral of that. It becomes y to the 6 here over 24 because we multiply 6 here in the denominator. And then this one becomes y to the fourth over 4. They canceled 4. Next, this one is becomes y cubed over 3. It's there. And then 8, this becomes y squared over 2. And 8 over 2 is 4. So that is why it's minus 4y squared. Now evaluate that from 4 to negative 2. Substitute 4 first, then minus substitute the negative 2. The same answer. The answer is also 36. Okay? Next. Again, class, that is for your type 1 and type 2. Now we have this one, example number 5. And we change also the variable here. Um, This is sine of y squared dy dx 0 to 1 then x to 1 there. Therefore, since this is 0 to 1 class and then this is dx here in the last part, so your d, this is the boundary of your x 0 to 1. And then for your y, since dy is here inside, we have here it's bounded from x to 1. So x is less than or equal to y less than or equal to 1. Now, we sketch this region D in figure 15. Then from figure 16, we see that there is an alternative description of D. So another description of D is this one. As you can see there, your x is bounded from 0 to 1. And your y here is bounded from x to 1. It means that since your x, the lowest number of your x is 0, so if you make this 0, your y is also bounded from 0 to 1. You have this one. Again, this is the alternative. Now, your x is bounded from 0 to 1, and your y is also bounded from x, which is here. X is bounded by y, bounded by 1 also. Therefore, your x is also bounded by y. So we have here 0 less than or equal to x, less than or equal to y. And then we solve this integral. So the integral um 0 to y here, sine of y squared. So since this is the interval for x, so dx must be here first. Okay, now 0 to 1 is the last one here, so that's for your y. That is why dy is in the last part here. Now we solve the integral. um this is sine y squared. Okay, by the way class, do you know why they change it? They change it class because it's impossible to do in the finite term. We have there sine of y squared. How to integrate that in terms of y? We have here dy. So you have to integrate that in terms of y. Now we apply um, the one that the d, the other d there, the alternative description of your d. You know why? Because if dx is the first integral here inside, so your sine of y squared class is considered constant. Correct? Your sine of y squared is considered constant. Okay. Now, since this is constant, the integral of this, just multiply it with x. Correct? So that is why it's there x, then sine y squared, evaluated from x is equal to y, x is equal to 0. Now you substitute here y, it becomes now y sine y squared dy. Okay, plus it's easy now to take the integral of your y sine y squared because the derivative of the y squared is y, right? It's 2y. And y is there already. There's a y in the beside your sine y squared. So this is easy to integrate now. The integral of this is equivalent to negative 1 half cos of y squared. Again, um, after this, evaluate that from 0 to 1, then substitute there 1. So we had this result 1 half minus cos 1. 1 half times 1 minus cos 1. Okay. Plus in the choices in your test, sometimes they are written in 4 decimal places. So for this one, for example, if you encountered something like this and then the choices are in 4 decimal places, convert this to a decimal. And then also for sometimes, like your calculator can answer only the decimal part and they cannot reduce it with a square root or something. So you have to solve all the choices there such that it's equivalent to the decimal number that you solve. Okay? That's vice versa. And that's it. This is now the answer. Okay, next. Oh, short quiz. Do we have a short quiz? Okay, later. Our quiz class will be given next week. I will not give you, no, not next week. It should be next meeting. Okay? We're still in a hurry now. Okay, now next, let's proceed with the chapter 2, part 2. It's there already in your LMS. Chapter 2, part 2 is the change of variables in a double integral. Okay, before we start, and it's nearly your 10-minute break. I can now give you your 10-minute break first, and then this is your last 10-minute break. Okay. Okay, it's time already. Wait, where's that? Okay, I still share the screen. Is this chapter 2, part 2? What is this? Chapter 2, part 2. Slide 13. Okay, so Jacobian of the transformation T given by x of g of uv and y is equal to h of uv. So we have here the partial of xy. Okay, these are the variables x and y in your function here. And then we take the derivative of this. We have to solve it over partial of u v. Okay, so to do this, first we have here partial of u over partial of x over partial of u. This is just the discriminant. Okay, next, as you can see here on top, they're all partial of x. And the second row, we have here partial of y here. Now here in, it looks like a first column, they're both partial of u here. In the second one, they're both partial of v here in the lower part. Okay, so it's there, partial of x over partial of u, partial of x over partial of v, partial of y over partial of u, and then partial of y over partial of v. Now to compute the discriminant, you multiply this two. You have here partial of x over partial of u times partial of y over partial of v minus you multiply this two also. Partial of x over partial of v times the partial of x over partial of u. And that's it. So as you can see there in the multiplication, they have different variables here. X, y, u, v. Here x, y, v, u. Okay. So actually, class, the absolute value of that is your delta A. Your delta is dot 1 times the del U times the delta V. Okay? So we have there, this one is your region S, and then this one class is your region R. So your S is in the UV plane, where your Rij is in the XY plane. Okay, so what to do? We replace everything by U there and the V, and we are going to get the double integral with respect to the S here, the region S. Okay, and then we have there delta U over delta V. So for this one, just change them to du dv later. Okay, so this one, your delta A, change that to dA, and then just copy the formula there, which is this one. The absolute value, the Jacobian transformation, and then we have du times dv. Now, um, again, that is for the change of variables in a double integral. So first here, the given here is x and y. And then here, the variables now is the u and the v. So we change it with u and v variables. Okay, here is another example. What if your x is written in polar coordinates? So instead of u and v, we use their r and theta. So your x is r cos theta, your y is r sine theta. And we solve already the Jacobian of t which is this one. Okay, so as you can see here, partial of x over partial of r, because this is r here, the first variable, partial of y over partial of r, partial of x or partial of theta, then partial of y over partial of theta. Multiply this. Oh, wait. What they did there is they solved it already. This is partial of x over partial of y. If you go back in the equation, your x is equal to r over cos theta. So if you take the derivative of x over r, the partial of x over the partial of r, okay, your r is the variable there, then cosine theta is just considered constant. So that is the derivative, right? Over partial of r, your y there is r sine theta. So the constant is just the sine theta. Take the derivative, it's the derivative, sine theta. Now next, partial of x over partial of theta. If you go back in the equation, your x is equal to r cos theta. So this time, since we are going to solve it with respect to theta, your r now is the constant. So your theta is inside the cosine. So what's the derivative of the cosine? Negative sine. So that becomes their negative r sine theta. Next, partial of y over partial of theta. So go to your, sorry, you go to your y, it's r sine theta. Your theta is here inside the sine, and your r is just considered constant, so your r will stay there. Now, what's the derivative of your sine theta? It's cos theta, so that becomes r cos theta. Now multiply this. Cos theta times r cos theta, we have r cos squared theta plus, no, not plus, it should be minus the product of the two here. So minus and then sine theta times the negative r sine theta. So minus and then there's a negative here, so it becomes plus. Then r and then sine squared theta. Now you can factor out r there. And what's happened? Why is this equal to r? Okay, class, we have a identity that the cosine squared theta plus the sine squared theta is equal to 1. So when you factor out r there, r is multiplied to that one, cos squared plus sine squared, and that's equal to 1. So r times 1 is just r. So replace that with r. So it's here r, and then dr d theta. And then this one, f, you substitute your x there. Your x must be r cos theta. And then r sine theta for your y. And please remember also, if you can find it here in the equation, for example, you have there x squared plus y squared. Your x squared plus y squared is equal to the r squared. So you have to change it to r squared because you are going to change all the variables here by r, right? And that's it. And then there is no example to that one, actually. So this one now is another example from x to y there, and then we have u and v, and your s is here already. It's bounded from 0 to 1, and then your v is from 0 to 1. So this is now easy to integrate, correct? Okay, so let's start with the x. Mm, it says there that we are going to find the image of the square S. This is your square S from 0 to 1. This is your U, 0 to 1. And then your V is from 0 to 1 also. It's there. So write the graph here. Then this one, so it's until here only. So it becomes 1, 1 here. This point is 1, 1. Okay, and you can form this square from this one because your u is from 0 to 1 and your v is from 0 to 1. Okay, you have now this square. All the points there, u, v. Okay, so if your v there is and u is 1, substitute it here. That is now the point 1, 1, which is this one, 1, 1. Okay, okay, so we have that square. Next, we have to solve the value of your x. class. Okay. And then we form this. This is the image of our S. Okay. So let's start with when V is zero. When your V is zero, your V has has too many values, right? From 0 to 1. So first here in S1. In your S1 class, as you can see here, your V here is actually 0, correct? In S1, your V there is 0 because this is the line V is equal to 0. This is V. So this is V is equal to 0. Now V is equal to 0, partner that with your U from 0 to 1. Now from the given equations, substitute it there in your x and then in your y here. Now if your v here is 0, x is equal to u squared. And if your v here is 0 and your y is equal to 2uv, your y there is 0. So you have there your x is equal to u squared and then y equals 0. And so since your u is bounded from 0 to 1, what is your u squared? If you square all the numbers there in the u, your x is also from 0 to 1, correct? You try it. You substitute the values of your u there, the 0, example 1 half, this part of your u, and then 1, you substitute it here in your u squared. The answer is also between the 0 to 1. And that is now your boundary for your x also. So that is why it's here from 0 to 1 in your x. Okay, now next. So the map into the line segment from 0, 0 to 1, 0 in the xy plane. So which is this one. Okay, next. Second is the S2. Look at your S2 class. Your S2, this graph here, if this is the U is equal to 1, correct? This is U is equal to 1. So here, partner that with your V, 0 less than or equal to V less than or equal to 1. Now substitute U here. In the first equation, you have there 1 minus V squared. Substitute 1 here also in your U. So we have there Y is equal to 2V. Now, eliminating V to obtain this, correct? Your V here is equivalent to Y over 2, correct? Look at the second equation class here. Divide that by 2, divide 2, your V is equal to Y over 2. Substitute the Y over 2 here in your V. So V squared, which is equal to Y over 2, when you square it, it's Y squared over 4. So you have there your X is equal to 1 minus Y squared over 4. And since your V is from 0 to 1, when you substitute it here, so your X has value from 0 to 1 also, correct? When this is your V is 0, so V squared is 0, 1 is your X. Now if your V is 1, 1 squared, so 1 minus 1, it's 0, so we have there 0. Then if you substitute their fraction also, when you square it, then 1 minus that fraction, the answer is also between here from 0 to 1. So that is now your value of your X from 0 to 1. So here, from 0 to 1 is your x, and then the graph of this 1 minus y squared over 4 is this graph. Okay, again, we graph it from 0 to 1 value of the x, sorry, what is this? From value from 0 to x to 1 only. Only. Okay, next. Look at your S3 there. For your S3, that line there is equivalent to V is equal to 1, correct? Now partner that with your U. U is less than or equal to from 0 to 1. Now substitute your V here as 1. So you have there U squared minus 1. And then 1 here also. So you have there 2U. Transfer the other side to 2. So your U is equal to y over 2. Then substitute that in your u and you will get this y squared over 4 minus 1. Now, the value of your u there is from 0 to 1, right? You substitute it here when you square it. Your v there is 1. So minus 1, you substitute it there. The values of your x now class is between negative 1 to 0. Correct? Because when your u there is 0 minus the v squared, our v squared is 1 because this is v is 1 here. So minus 1, 0 minus 1 is negative 1. And then when your u is 1, so 1 squared minus, again, your v there is 1, 1 minus 1 squared, it's the same. So the answer there is 0. So 0. So your value of your x is between the negative 1 to 0. So in the graph here, from negative 1 to 0, so this is your negative 1 value of your x, going to the 0 is this graph. X is equal to y squared over 4 minus 1, which is this. Okay? Now, S4. Go to your S4. S4 is this. Your S4 is the what graph? Is what graph? This is your u is equal to 0, correct? This is u here. This is a vertical line. So that is u is equal to 0. Partner that with your v from 0 to 1 is your v. Now substitute the u here be 0. So x is equal to 0 squared minus v squared. So your x is equal to negative v squared, which is here. X is equal to negative v squared. Now, if your u here is 0, so 2uv becomes 0. So y is equal to 0. Hmm. And y is equal to 0 is this line here. And since your x is negative v squared, okay, now substitute the value of your v. First 0, so the answer is 0. Now if you substitute 1 there, so negative 1 squared is negative 1. So your x is between negative 1 to 0. That is why it's here, this line. From negative 1 to 0. And that completes this shape. Okay? And that's it. The R here is the image of your square S. Okay, next. We have this one. Use the change of variables. You have their x is equal to this. Oh, that's the same. The same equation from the previous one. To evaluate the integral, the double integral of y dA, where R is the region bounded by the x-axis, then parabola's y squared is equal to 4 minus 4x, and then y squared is equal to 4 plus 4x. Y is less than or equal to 0. So as you can see here, your R, look at the R class. Is it familiar? Now, solve the value of the x there. This one, what will happen if you solve the value of the x? Transfer the 4 to the other side, it becomes y squared minus 4. Divide negative 4 both sides. Divide negative 4 both sides, it becomes 1 minus y squared over 4. And that one is here, actually the previous one. 1 minus y squared over 4, which is this one. Oh, so this is your R, actually. This is your region. We go back. This is y squared is equal to 4 minus 4x. If you solve the x here, transfer the 4 to the other side, it becomes y squared minus 4. Divided by 4 both sides, you have there y squared over 4 minus 1. And y squared minus 4 minus 1 is here. And this is the graph. Therefore, since that is your R class, the image is the S. The image is this S, which is bounded from 0, 1 to 0, 1. Okay? And we can solve now the integral. Okay. So the first one here is for your u, and then the 0, 1 here is for your v, this second interval. Now we solve the partial, no, the Jacobian of t. We have here partial of x or partial of u, partial of y, partial of u, partial of x over partial of v, and then partial of y over partial of v. So again, the derivative of x here with respect to u, we have here 2u. the v squared is 0. Next, partial of x over partial of v. So as you can see here, there's a u, so derivative this is 0. So with respect to v, the answer is negative 2v, which is here, correct? Now partial of y over partial of u. So here we have 2uv. So your u is the variable, so 2v is considered constant, so that is the derivative, 2v. Now next, partial of v over partial of y over partial of v. The derivative here with respect to v is 2u because 2u is u now is considered constant. Now multiply this, it's 4u squared minus multiply this, it's a negative 4v squared. So minus negative becomes plus. So we have here 4u squared plus 4v squared. Okay, and this one is always greater than 0. This is your Jacobian now. And take the absolute value of that. Now class 4 is always positive. Your u squared is always positive. Your v squared is always positive. So if you take the absolute value, still the same. It should be like this. Just factor out 4 there. Now, the one that we're going to solve is the y dA, the double integral of y dA. And we have the value of your y already. Your y is equal to 2uv, so we have to substitute it here. 2uv. Again, the absolute value of your Jacobian and then dA. Now, we take the double integral. So 2uv. Substitute your Jacobian. It's 4 times u squared plus v squared. Okay. Since the integral is from 0, 1, 0, 1, so du dv are here now. Can you interchange them? Yes or no? The answer is yes, because they just have the same integral from 0, 1, 0, 1 here. So start with du first. Okay, again, you can solve it if you use dv du also, and you have to get the same answer, which is 2. Okay, now solving this, 4 times 2 is 8. Put 8 outside. Now uv times u squared, it's u cubed v. Now uv times the v squared here is uv cubed. And that's it. We just multiply them. And now take the derivative with respect to u. Your u here is u cubed. So derivative of the integral of that is u to the fourth over 4 or 1/4. U to the fourth. Just copy v there. Plus here, the integral of u here, this is u to the power of 1 only. U. So make this u squared over 2. So that's it. 1/2 to u squared. And then copy v cubed because v there is considered constant. Evaluate that from 0 to 1. Substitute now only 1 there because when you substitute 0, it will become 0. So substitute 1 here becomes 2v. Why 2v? Because you multiply the 8 there to the 1/4. Now plus 8 times 1/2 here is 4. And then substitute 1 in your u, it becomes v cubed. So v cubed will remain. Now copy dv. So they're all now v, and then you integrate it from 0 to 1. Your calculator can solve this. The answer is 2. Now, if you solve the integral of this, 2v is equal to v squared. And then the integral of 4v cubed is v to the fourth. Now, do not substitute the 0 because it will be 0. Just substitute the 1 there. So 1 squared plus 1 to the fourth is just 1 plus 1, which is equal to 2. Okay, next. We have this one. Evaluate that integral e to the power of x plus y over x minus y dA, where R is a trapezoidal region with the following vertices. Okay, so we are going to get the image of the R here. Okay, now how to do that? First, your function there has an x and y, so you let u there be x plus y, and then your v is equal to x minus y. So what are we going to do is we change the variables now. We change the plus there with u, and then the x minus y with v. Okay, so what are we going to do now? What is your x from this one? If you solve the x here, why is it x is equal to 1/2 of the u plus v? Do you have an idea, class? Why is it equal to this? If you solve this one, the x here, u minus y, correct? Your u minus y is equal to x. How about this? If you solve the x here, it's v plus y, correct? It's v plus y is equal to x. Now, why is it x is 1/2 of the u plus v? It says here, um, it is obtained by solving the equations 10 for x and y. So when you solve there the value of the x, okay, um, your x here is equivalent to u minus y, correct, class? And you substitute it here. No, 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 wait. Uh, this is what are you going to do? You solve the y here, and you substitute it here in the second, and then solve the x, and you got this. Okay, so I'll do it this way. U minus x is equal to y. Am I correct? Correct. So your y is u minus x. Replace here. This is now minus y, right? Your y becomes now u minus x. U minus x. So minus that one, it becomes minus u plus x. So minus u plus x here. So transfer the u to the other side. It's now u plus v. And here we have x plus x. X plus x here is 2x. Mm, that will make sense. Multiply that with 1/2, and the other side is 1/2. So your x is 1/2 of the u plus v, and we have this one. Similar with your y, what to do there is you solve the x here. It is u minus y. Substitute it here in your second equation. Replace the x here by u minus y. And then solve the y here. Your y value must be this. Y is equal to 1/2 of the u minus v. Okay, next. We solve now the Jacobian um, equation. First, partial of x with respect to u. So your v here is considered constant. Derivative of this is 0. So we have only 1/2 u. Derivative of the 1/2 u with respect to u is just 1/2. Next, partial of x over partial of v. Here your u is now considered constant. So this becomes 0. Derivative of this. So 1/2 times v. The derivative is 1/2. Next, for your y there with respect to u. So minus v here is considered 0 because derivative of that is 0. So we have there 1/2 u. Derivative with respect to u is 1/2. Next, partial of u over partial of v. So u here becomes 0 because the derivative of this is 0. And we have minus v there. Times 1/2, it's minus 1/2 v. Derivative with respect to v is negative 1/2. Now multiplying 1/2 and negative 1/2, you have negative 1/4 minus 1/2 times 1/2 here is also negative 1/4. So negative 1/4 minus negative 1/4 is negative 1/2. So this is now your Jacobian of t. So go back. Mm. For the region S, your region R is bounded by this one, correct? Okay, where we got this? Okay, you go here. You have these points, class. 1, 0, 2, 0, 0, -2, and 0, -1. If you plot the 4 points there in your R, you can form a trapezoidal region, which is this. The blue one here, that is a trapezoid, if you can imagine it. Here's the base, upper base, this is the lower base, and this is this sides. So we have there, this point here is the 1, 0, 2, 0, 0, -1, and 0, -2. Now we get the lines. What are the equation of the lines? So first, this line here on top, this line here is this y is equal to 0. The second line here, we have 2 points, the 2, 0, and the 0, -2. Plus, can you take practice of this? If you have a 2 points, what is the equation of the line there? Yeah, you can see that process in the high school topics. Yeah, you have that already. If you are given 2 points, you solve there you have to get the equation of the line, and then you can have this one: x minus y is equal to 2. Next, this line here, negative 1, 0, and the 0, -1. The line here is x minus y is equal to 1. And then the last here, this line, this is actually equal to, this is a vertical line, which is straight to 0. So this is x is equal to 0. So we have these lines. Now, how to get the S region? Okay. Now, for the S region, plus when your y is 0, you go here. Look at class. When your y is 0, look at here. Or not here. Hmm. Here. When your y is 0, transfer there 1/2. So multiply this by 2. So 2 times 0 is still 0. And you have your u minus v. Transfer the v to the other side. Your u is equal to v. And which is this. U equals v. Okay? It says here, you substitute the values there from either equations 10 or 11, and you can have this images. Yeah, because it's from here, equation 10 and equation 11. Okay, next. It's safer class if you substitute it here in your 11, because only one y here and only one x that you can substitute. And that's it. Also, you can use the other ones. It's fine because you can see it later. Next, your x minus y is equal to 2. So this is easy if we use the equation number 10. Since your x minus y here is equal to 2, so your v equals 2. And that's it. It's here. Your v equals 2. Next, when your x is 0, safer here. If this is 0, substitute there 1/2. Multiply 1/2 to the other side, it becomes -2. Multiply the 2 here, it becomes 2 times 0, it's 0. So the remaining here is u plus v. Transfer the v to the other side, so your u is equal to the negative v, which is this one. U is equal to the negative v. Lastly, x minus y is equal to 1. We use equation 10. Substitute your x minus y here, which is equal to 1, and we can solve v is equal to 1. It's here. Now we graph the 4 lines. First, u is equal to v is this one, is this line. U equals v. Next, v is equal to 2. V equals 2 is here on top. That's the line for your v equals 2. Next, u is equal to negative v is here. This line. Last, we have v is equal to 1. We have this line here, the lower line. Okay. So as you can see there, for your s is bounded from, your v is from 1 to 2. And then your u is bounded from negative v to v here. So these are the two functions, right? From negative v to v. And we substitute it here in our double integral now. Your u e to the power of x plus y over x minus y. This is the given, right? Which is there. Substitute it now. X plus y is u, so that's e to the u over v. And then multiply the Jacobian, take the opposite value of that. Your Jacobian value is negative 1/2 here. So if you take the square root of that, the result must be positive 1/2, which is here 1/2. Then, right, du dv. Okay. Now, since this is du, your u is from negative v to v, so it's here negative v to v. And then your v is from 1 to 2. We have here 1 to 2. Okay, and that's it. Now, we write 1 half to the other side, then evaluate your e to the u over v by du. So if this is du, the answer is v e to the u over v. Evaluated from negative um, v to v. Now substitute v first in your u, it becomes e to the 1, correct? And then there's a v here outside. Then after that, we substitute the negative v there. Negative v over v is negative 1. So we have this one. E minus e to the negative 1 v dv, evaluated from 1 to 2. And then when you take the derivative of this, the integral of this in dv, you have there v squared over 2. Then integrate that from 2 to 1, and then you can solve this value. It's 3/4 times e to the, uh, 3/4 e minus e to the negative 1. Okay? That will be the value. Next, applications of double integral. Density and mass. Oh, wait. It's my other class. We end it here. Oh, wait. I don't know if we end there. Wait. The list is here. It's now 3:30. I didn't discuss this. So I guess I didn't discuss this yet to my previous class. We are advanced and it's fine. We still have 20 minutes to discuss this one. Okay. Um Again, class, I will not give you the discussion about getting the equation of the line if given 2 points are there, how to get the equation of the line. So you have to study that one. Yeah, we end at slide number 13, and then this one is now slide number 14. So we are advanced already. It's okay. Um, so density and mass. So example one, charge is distributed evenly over the triangular region D in figure 3. Figure 3 is here. So that the charge density at xy is the sigma of xy, which is equal to x times y, or xy, measured in columns per square meter. So that's c over meter squared. Again, this is you read it like columns per square meter. Okay, find the total charge. So we're going to get the total charge. So first we get the double integral, and then um, xy. Actually, this is the formula, sigma of xy. So substitute here xy. And then why is it dy dx? So go here in the figure because this figure is given already. Now, as you can see, the y is, it will go up. Okay, it will go up. So this one is the lower boundary of your y. So your y here is net 1 minus x here in the lower. Then going up, it's y is equal to 1. So it should be 1 there. So from 1 minus x to 1. Okay. So if you write this, your 1 minus x is less than or equal to y, less than or equal to 1. Okay. Now for your x there, it's really clear. Your x is from 0 to 1. Correct? Look at the value of your x here. the value of the x that we consider is only from 0 to 1 here. So that's why it's 0 to 1 there, then dx. Now, we solve the integral of xy. The integral of x, just copy it because it's dy here. So just solve the integral with respect to y. So we have here y squared over 2. So then copy x. Evaluate that from 1 to 1 minus x. So substitute 1 first. We have there there's is x over 2, right? So we write the x over 2 outside. Substitute 1 in your y squared, it's 1 squared minus, you substitute now the 1 minus x squared, minus x, so you have your 1 minus x squared. Now if you solve this one, class, this is 1 squared is equal to 1 minus 1, and then yes, because what is 1, what is 1 minus x squared? If you square that, the result is 1 minus 2x plus x squared, correct? Then change the sign there, it becomes minus 1 plus 2x plus x minus x squared. So it becomes this 2x squared, 2x, just 2x minus x squared. Then there's an x here. Then multiply the x there. It becomes 2x squared minus x cubed. Then since there's a 2 here, so we write 1 half to the here. We write it first, 1 half. Then the integral of this one, 2x squared minus x cubed dx, evaluated from 0 to 1. So your calculator can automatically solve this already. And but if you want a detailed solution, if you want a detailed solution, this becomes 2x cubed over 3 minus x to the fourth over 4, evaluated from 0 to 1. Now substitute there 1. Okay, wait, copy 1 half first. Please do not forget the 1 half. Substitute 1 first, and then do not substitute the 0 anymore because the 2 becomes 0. So only 1 there, and then the answer is 5 over 24. Okay, can you try this? Please, class, you can try this one. You can type it directly in your calculator, and then your calculator will give this answer, 5 over 24. Again, if you do not want to waste time during your test, for example, if you get the first integral already, so you can calculate that one, and then your calculator will give you an answer. Okay. Next, we have moments and centers of mass. Our time is 15:36, so we still have 14 minutes. So it's okay. We can finish this. Mm. Find the mass and center of mass of the triangular lamina with vertices. The three vertices are here. If the density function rho of xy is equal to 1 plus 3x plus y. And the formulas are there on top. So first, you have to solve the m first because you need it in your x bar and then your y bar. Okay, m here, class, is the mass. Find the mass, so that is your m. If we find the center of mass, class, is this coordinate, the x bar, y bar. The coordinates x bar, y bar of the center of mass of the lamina. So which is this? This is now the center of mass. So we have to solve the x bar and then y bar. And when you're done solving the two values, you write it inside a parenthesis and put comma between them, and that is now the coordinate of your center of mass. Okay, now let's start with this formula, double integral, and then rho of xy dA. Okay, now what happened to the numbers here? Why is it there's a y minus 2x? Okay, so you have their 3 points. So what are you going to do with the 3 points? You have to plot them in the graph. And this is the graph. Okay, now class, you have to go from here going up. Okay, because this is a triangle. So for your y, you have going down from here downward going up. Your x is here going here. So your x is from 0 to 1. Okay, your y is from 0. This is the line y is equal to 0 in this lower going here up in this line. And then this line is y is equal to 2 minus 2x. Okay, this equation of the line is formed by the 2 points. You have there 0, 2, and 1, 0. Again, you have to do some practice there how to get the equation of the line. You are given only 2 points. So, but I will give you some hints there. You have to solve the slope. The slope formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here, for example, if this is your 0, 2, you make the first 0 here as your x sub 1, the partner is y sub 1. Here, 1, 0, this is your x sub 2, your y 0 here is, your 0 here is your y sub 2. So minus the y there, so 0 minus 2 over 1 minus 0. 1 minus 0 is 1. Then 0 minus 2 is negative 2. So that's negative 2 over 1. It's equal to negative 2. That is now your m. Your m means your slope. And that negative 2 must be beside an x. So which is here. It's negative 2x. It should be beside the x. Now, what is the formula of the line? It's y is equal to mx plus b. M there is the slope, so you have here negative 2x. Now, the b part is when your x there is 0. And we have this point already in the line. They have the 0, 2. And it will touch actually the line of your y there. So this 2 here is your y intercept again, and that is the value of your b. Can you have there y is equal to mx plus b? Your b there is the y intercept, and that is the number 2 here, so that is why it's here. Y is equal to 2 minus 2x. This is now the equation of the line. Again, do some practice there how to get the equation of the line. Now, solve the m. So your m is for your y class, the boundary of your y is from this line, which is y is equal to 0 going up to 2 minus 2x. And that's it. It's here from 0 to 2 minus 2x. This is the interval of your y. You have the dy. And then for your x, it's from the interval 0 to 1. Okay? And it's there. You solve this. The integral of 1 is y. Yeah, we just have to write a variable beside the constant, right? If you have there a constant. So the integral of 1 is y. The integral of 3x. Oh, there's no y here. So this is considered constant. Just put y beside it. So you have there 3xy. Then the integral of y becomes y squared over 2. Evaluate this from 0 to 2 minus 2x. Now substitute the 2 minus 2x in the values of your y here. And don't need for you to substitute the 0 because the whole thing becomes zeros. And then after that, you solve, you add everything, and you can simplify it to 1 minus x squared, which is this one. Now solve the integral of this. This is 1. The integral of that is x. Again, it's just constant, so just write x beside it. Then we have there x minus x squared, so it becomes negative x cubed over 3. Then just copy 4 there. Then evaluate it from 0 to 1, and the answer is 8 over 3. And this is now your m. This is 8 over 3. Now, what is the value of your 1 over m class? Your 1 over m is the reciprocal of your m. So, if your m is 8 over 3, your 1 over m is equivalent to 3 over 8. Okay? Then solve the double integral again. So as you can see here, the x bar has an additional. We multiply x in the row function. For the y bar, there's also an additional here. In the row function, multiply that with y. So here, If this is your row function, this becomes, when you multiply it with x, this becomes x plus 3x squared plus xy. And that is what are we going to do with our x bar. So it's here, 1 over m. Okay. So since what your m there is 8 over 3, the 1 over m becomes 3 over 8. Okay. Now, multiplying x to your row function, yeah, I told you this becomes x plus 3x squared plus xy. Okay. Now, the same numbers that you're going to use, it's evaluated from 0 to 2 minus 2x, and that is dy. Then your x is from 0 to 1. So dx must be the last here. Now, solve this with respect to y first. This is x, there is no y. The integral of this, just write a y beside it. So it's here xy. Next term, we have 3x squared. There is no y again, so this one is considered constant. So just write y beside it. So 3x squared y. Here xy. Oh, we have y there already. The integral of your x there is considered constant. So just copy x and then y. The integral of that is y squared over 2. Evaluate that from 0 to 2 minus 2x first because you solved the integral already. Now you substitute it here in your y, here also, and here. And then solve everything and you can simplify it to this, x minus x cubed. Okay? Now take the integral of this. In your calculator, you can solve this directly and you can get there a 3 over 8 value. Okay. Now what happened here, class? This is 3 over 8. Why is this now 3 over 2? This is now 3 over 2, class, because um, when you substitute there the 2 minus 2x, um, the numbers here are now divisible by 2, correct? And then why is it? It becomes there 3 over 2. Yeah, if you combine all of this. Okay? And here now, the last one, the y bar. So I cannot give you the detailed answer for this one class, the detailed solution, but you have to try that one. Okay? Just substitute it here in your y's here and then add them. Maybe the result has a number on top and maybe the number on top is 4. Yeah, you can factor out a 4 there and then times 8. There's 8 here. So 4 over 8. So it becomes 3 over 2 here. Yeah, that's for sure. You can have a 4 factor there on the top. Next, y bar. For your y bar, again, 1 over m, and then you multiply y in your row function. So this becomes now y plus 3xy plus y squared dy dx. We still have 5 minutes. So the integral of this with respect to y, we have y squared over 2. This one becomes 3x, and then the integral of y squared over 2, plus your y squared becomes y cubed over 3. Now substitute 0 and then 2 minus 2x. No need to substitute 0 there, class, because all the terms there become 0. Just substitute the 2 minus 2x there. And then when you have that, mm, you can simplify it with a 3 in the denominator. That is why the 3 will be cancelled. And then there's a factor there on top, which is, I guess, it's 4. They're also on top because it's here 8 and 2 here. So the denominator here becomes 16 in the lower part. And then there's a 4 there on top. So 4 over 16 is 1/4, which is here 1 over 4. Okay, that is the for sure that you can solve. And then this is not the reduced form. If you do that, we have there 7 minus 9x minus 3x squared plus 5x cubed. Now integrate this. Again, if you do not want to waste your time, so if you substitute the y here, 2 minus 2x squared, and here also 2 minus 2x squared, here is 2 minus 2x cubed. Again, you can type it directly in your calculator and your calculator will give you 11 over 6. Okay? But since we have a detailed solution and not so detailed, because when you substitute it here, there is no values that you can see it. Again, if you substitute it there, this is the next one. You can reduce it like this. So take the integral of this. We have 7x minus 9x squared over 2. The x squared becomes x cubed over 3. Then cancel the 3 here because there's a 3 here. And then we have 5. Then the x cubed becomes x to the fourth over 4. Evaluate this from 0 to 1. Substitute only 1 there because if you substitute 0, all the terms there becomes 0 already. So just substitute 1 there and then solve everything. The answer is 11 over 6. And that is now your y prime. And the center of mass, by the way, it's there in the lower part. You can see it. I'll just make this lower. And the center of mass is the point x bar, comma, y bar. So we have here 3 over 8, comma, 11 over 6. And this is your center of mass. And the next topic is about this. And that's it. By the way, everyone, thank you for coming and see you next meeting. Goodbye.
Thank you, Batija.
You're welcome. Goodbye, everyone. Probability.